Dive into the world of hormonal regulation with us. Discover how the hypothalamus and pituitary gland orchestrate a symphony of signals to peripheral glands, ensuring our body's balance. Learn the pivotal roles these axes play in metabolism, growth, and stress responses. Plus, explore how GIT hormones are key players in digestion. Join us to unravel the mysteries of our body's hormonal harmony. Journey deeper into the body's endocrine ecosystem, focusing on the adrenal glands, reproductive system, and gastrointestinal hormones. Understand how adrenal hormones fuel our fight or flight response, and the intricate hormonal interplay governing reproduction. Discover the gastrointestinal hormones' critical roles in digestion and nutrient absorption. This exploration will equip you with knowledge about these vital processes, enhancing your grasp of the body's hormonal orchestra. Nestled above each kidney, the adrenal gland is a crucial part of our endocrine system. It's divided into two main parts, the adrenal cortex and the adrenal medulla. The cortex, the outer layer, is a steroid hormone factory, producing vital hormones that regulate metabolism, immune response, and stress. Meanwhile, the adrenal medulla, the inner part, focuses on catecholamines like adrenaline. Together, they ensure our bodies can adapt to stress and maintain balance. Diving deeper into the adrenal cortex reveals a structured powerhouse of hormone production, segmented into three distinct zones. Each zone has a specialized role, orchestrating a delicate balance of mineralocorticoids, glucocorticoids, and sex hormones. These hormones are pivotal in managing our body's response to stress, regulating metabolism, and influencing our mineral balance. Understanding the adrenal cortex zone sheds light on its critical functions in maintaining health and well-being, making it an essential topic in the study of human physiology. The hypothalamic-pituitary-adrenal axis forms a crucial part of our body's response system to stress. It starts with the hypothalamus releasing CRH, which signals the pituitary gland. The pituitary, in turn, releases ACTH, reaching the adrenal glands. Here, ACTH stimulates cortisol and androgens production, key players in managing stress and metabolic functions. This intricate dance of hormones ensures our body can adapt to recover from stress, highlighting the HPA axis' central role in maintaining balance and health. In our body's quest for balance, cortisol plays a pivotal role. Originating from the adrenal cortex, its production is a finely tuned process involving the hypothalamus and the anterior pituitary gland. This process is governed by a negative feedback loop, ensuring cortisol levels are kept in check. Elevated cortisol signals the hypothalamus and pituitary gland to dial back, maintaining homeostasis. This elegant system exemplifies our body's intricate mechanisms for regulating stress and ensuring our well-being. Diving deeper into the adrenal cortex secrets, we uncover the initial step in cortisol production. It all starts in the zona fasciculata cells, where cholesterol undergoes a transformation into pregnenolone, thanks to cholesterol dysmolase. This marks the journey's beginning, leading to progesterone and eventually cortisol. Once cortisol is released, it doesn't roam free. About 90% binds to plasma proteins like transcortin and albumin, ensuring it stays longer in our system and distributes evenly. This intricate process highlights the body's precision in managing stress responses. Cortisol, our body's stress hormone, follows a unique daily rhythm, peaking at dawn and dipping at midnight. This natural cycle ensures we're alert as we wake and calm as we rest. But when stress strikes, be it from pain, anxiety, or physical exertion, cortisol levels can surge, disrupting this delicate balance. Understanding this rhythm is crucial for managing stress effectively, keeping our cortisol levels in check, and maintaining overall well-being. Let's dive into how our body's cortisol clock can be influenced by our daily activities and stressors. Once cortisol has fulfilled its mission, it undergoes a transformation, becoming cortisone through the enzyme 11-beta-hydroxysteroid dehydrogenase 2. This reversible change is just the beginning of its journey to exit the body. The liver then takes center stage, metabolizing cortisone and preparing it for excretion. Finally, through bile salts and urine, cortisone says its goodbyes, leaving the body. This process ensures that cortisol levels are kept in balance, preventing the potential harm of prolonged exposure to high cortisol levels. Cortisol, often dubbed the stress hormone, plays a pivotal role in our body's response to stress. It helps us adapt by increasing glucose in the bloodstream, ensuring our muscles and brain have enough energy. It mobilizes amino acids and lipids, providing vital building blocks and fuel. Cortisol also keeps inflammation in check, aids in wound healing, and boosts red blood cell production. Importantly, it manages our body's electrolytes and fluids, reducing sodium loss and promoting potassium excretion, maintaining balance even in stressful times. Aldosterone, a key player in our body's electrolyte and fluid balance, is uniquely regulated. Produced in the adrenal cortex, it fine-tunes sodium and potassium levels, essential for our health. Unlike many hormones, its control sidesteps the anterior pituitary, responding directly to changes in blood chemistry and pressure. This direct regulation ensures precise adjustments to maintain electrolyte balance, highlighting aldosterone's critical role in our physiological harmony. When our blood pressure dips too low, the kidneys release renin, sparking the renin-angiotensin-aldosterone system into action. Renin transforms angiotensinogen into angiotensin I, which is then converted into angiotensin II. Angiotensin II narrows blood vessels and signals the adrenal glands to release aldosterone, increasing sodium and water retention. This clever system boosts blood volume and pressure, ensuring our bodies maintain a delicate balance essential for health. Diving deeper into the adrenal cortex, we uncover disorders that disrupt hormonal harmony. Aldosterone hypersecretion, or Conn syndrome, leads to excessive salt retention and hypertension. Overproduction of cortisol manifests as Cushing's syndrome, marked by weight gain and skin changes. Conversely, Addison's disease reflects adrenal insufficiency, resulting in fatigue and low blood pressure. Understanding these conditions is crucial for managing their impacts on health. Aldosterone plays a crucial role in regulating our body's salt and water balance, but what happens when there's too much of it? Aldosterone hypersecretion, often stemming from adrenal tumors or conditions like Conn syndrome, disrupts this balance. It leads to excessive sodium retention, potassium depletion, and a rise in blood pressure, posing serious health risks. Recognizing the signs and seeking treatment is key to managing this condition and maintaining health. Cushing's syndrome arises from excessive cortisol, a hormone pivotal for stress response and metabolism. This condition can stem from various sources, including adrenal tumors or external ACTH-secreting tumors, disrupting the body's hormonal balance. Key symptoms to watch for include high blood sugar, sugar in urine, and distinctive fat distributions like the buffalo hump and moon face. Understanding these signs is crucial for early detection and management of this syndrome, highlighting the importance of hormonal health in our overall well-being. Adrenogenal syndrome results from excessive androgen production by the adrenal cortex, leading to a spectrum of physical changes. In adult women, it manifests as increased body hair, voice deepening, and menstrual disruption. Newborn girls might have ambiguous genitalia, while young boys could experience early signs of puberty without true testicular development. Interestingly, adult men often show no overt symptoms, making diagnosis less straightforward. Understanding these diverse impacts is crucial for timely intervention and management of this complex condition. In this segment, we delve into adrenocortical disorders, focusing on Addison's disease, a form of primary adrenocortical insufficiency marked by autoimmune destruction. This condition leads to deficiencies in vital hormones like aldosterone and cortisol, resulting in symptoms such as hyperkalemia, hyponatremia, and hypoglycemia. We'll also touch on secondary adrenocortical insufficiency, which stems from pituitary or hypothalamic issues, affecting cortisol levels. Understanding these disorders is crucial for recognizing their impact on health and stress response. Diving into the heart of our stress response, the adrenal medulla plays a pivotal role. Acting as an extension of the sympathetic nervous system, it's primed for action under stress, secreting the potent hormones epinephrine and norepinephrine. These hormones are the conductors of the fight or flight orchestra, enhancing blood pressure, blood glucose, and fatty acids to prepare the body for immediate action. Through the adrenal medulla, our bodies can swiftly respond to stress, showcasing the intricate balance of our internal systems. Dive into the world of adrenergic receptors, the critical links in our body's response to stress and excitement. These receptors, scattered across various organs, respond to catecholamines like norepinephrine and epinephrine. They regulate vital functions from the tightening of blood vessels to the acceleration of heart rate, the relaxation of airways, and the mobilization of energy reserves. Understanding these receptors illuminates how our bodies maintain balance amidst the challenges of daily life, ensuring we're ready for action whenever needed. Nestled beneath the adrenal cortex, the adrenal medulla acts as a pivotal force in our body's stress response. When the sympathetic nervous system kicks in, it secretes powerful hormones epinephrine and norepinephrine. These hormones orchestrate the fight or flight response, ramping up heart rate, blood pressure, and breathing, while also boosting energy availability. This rapid mobilization prepares our body to face emergencies, showcasing the adrenal medulla's vital role in our survival toolkit. In the realm of emergency medicine, two hormones play pivotal roles. Epinephrine, a lifesaver in anaphylaxis, asthma, and cardiac arrest scenarios, works by constricting blood vessels and dilating airways, ensuring oxygen flow. Norepinephrine, the counterpart, is indispensable for treating septic shock and critical hypotension by boosting blood pressure and prioritizing blood flow to vital organs. Together, they form a dynamic duo, safeguarding lives by stabilizing critical conditions. Diving into the reproductive system, we uncover a complex dance orchestrated by the hypothalamus-pituitary-gonadal axis. It begins with GnRH pulse from the hypothalamus, prompting the pituitary to release LH and FSH. These signals empower Leydig and theca cells to kickstart sex hormone production. The process pivots on converting cholesterol into pregnenolone, setting the stage for the creation of vital sex hormones. This intricate cascade underscores the marvels of human biology in gender-specific hormone synthesis. In the realm of female physiology, estrogens emerge as pivotal architects, sculpting sexual characteristics and ensuring reproductive health. These steroid hormones are synthesized in the ovaries' granulosa and theca cells, and the corpus luteum, acting as key players in the female body's hormone symphony. This process is not just about hormone production, it's about maintaining the delicate balance that defines female health and development. Progesterone, a key hormone in pregnancy, is synthesized from pregnenolone. This transformation, catalyzed by the enzyme 3-BHSD, occurs primarily in the corpus luteum and the placenta. Beyond its well-known role in pregnancy, progesterone also serves as an intermediate in the production of androgens and mineralocorticoids, highlighting its versatility. Its synthesis in the adrenal glands underscores the interconnected nature of our hormonal ecosystem, playing a critical role in our body's hormone balance. In the male body, the hypothalamic-pituitary-gonadal axis is a cornerstone of reproductive health, regulating key hormones. Luteinizing hormone kickstarts testosterone production from Leydig cells. This testosterone, while crucial for male traits, also tells the brain and pituitary gland to ease off on LH and GnRH production, maintaining balance. Additionally, testosterone can transform into estradiols, further fine-tuning this feedback loop. Meanwhile, follicle-stimulating hormone works with Sertoli cells to manage sperm production through inhibin release, showcasing the precision of hormonal regulation. In females, the dance of hormones is a delicate balance, orchestrated by the hypothalamus, pituitary gland, and ovaries. The hypothalamus releases GnRH, signaling the pituitary to secrete LH and FSH, which in turn stimulate the ovaries. Unlike in males, the feedback loop in females intricately varies across the menstrual cycle's phases, adjusting hormone levels to prepare for potential pregnancy or to commence menstruation. This complex interplay ensures the reproductive system's smooth functioning, highlighting the beauty of hormonal regulation. In males, the hypothalamic pituitary gonadal axis is crucial for reproductive health, controlling both sperm and testosterone production. It starts with the hypothalamus releasing GnRH, which triggers the interior pituitary to secrete LH and FSH. LH encourages testosterone production from Leydig cells, while FSH, with testosterone's help, promotes sperm production by Sertoli cells. Inhibin from Sertoli cells finally tunes this process by inhibiting FSH, ensuring a balanced production of sperm and maintaining hormone levels. This elegant feedback loop is essential for male fertility and overall hormonal harmony. In the male body, the hypothalamic pituitary gonadal axis doesn't just regulate testosterone. Surprisingly, hormones like estradiol and progesterone, often associated with female physiology, also influence this axis. These hormones participate in feedback mechanisms that affect the HPG axis, showcasing a complex network beyond testosterone alone. This intricate interplay is crucial for a comprehensive understanding of male hormonal health, highlighting the importance of considering all hormones in the regulation of male reproductive physiology. In the male body, the hypothalamic pituitary gonadal axis is a cornerstone of reproductive and developmental hormone regulation. It starts with the hypothalamus releasing GnRH, which prompts the pituitary to release LH and FSH. These hormones then stimulate the testes to produce testosterone and support spermatogenesis. Importantly, testosterone exerts a negative feedback on both the hypothalamus and pituitary, fine-tuning the production of GnRH, LH, and FSH to maintain hormonal balance. This feedback mechanism ensures the stability of male hormonal levels, crucial for health and well-being. Estrogens play a pivotal role in the body, far beyond just influencing female sexual development. They're key in promoting the growth of breast tissue and the differentiation of sexual organs, impacting both sexes. But their influence doesn't stop at reproduction. Estrogens also affect various target tissues throughout the body, showcasing their widespread importance in our overall health and well-being. Understanding estrogens' multifaceted roles offers insights into their crucial contributions to sexual health and beyond.